if you're checking it out in the future, thanks so much for joining. Appreciate it. Been working on this for the Google Summer of Code throughout the summer with Jack, Victor, and Pietor, who have really helped kind of guide me throughout this entire process. All props to them for their mentorship throughout this. If you want to try this, again, it's very in experimental demo stage. Right now, you should be able to clone, and then the branch we're on is week 11. I'll be updating this throughout the next couple days and then throughout the next couple weeks and so on. Right now, we had a strategy prior that was more or less a decomposition stage, and I'll go into that a little bit more, but I'll be really doing a lot of prompt engineering work and then fixing up a lot of the code structure. So I'll do a full kind of architectural diagram if you want to add anything to it, or if something is not necessarily benefiting you, but you want to extend it. I'll give some opportunities and to-dos in the code as well, and then point that out in a subsequent video at the end of the Google Summer Code. But kind of like if you're installing Tölvera and you wanted to just run a Tölvera sketch, it's the same thing with Poetry install. So it's all within the Poetry init. So if you want to check out this demo, one thing you will need to do is open up the environment example and then dump whatever your API key is here. We also have Ollama. So if you heard of Ollama, it's basically running local models on your hardware itself. The problem with a lot of what we found throughout the summer was a lot of the smaller models hallucinate a little too much. They're on Tai Chi syntax, which Tölvera was built on for a lot of the domain-specific language generation. So we have kind of a problem with a lot of the smaller models. We constrain the output a little too much, so you don't get these really cool, complex artificial life examples. Or if we let it be too creative, then we deal with a lot of these Tai Chi syntax errors, and you'll see that happen as you explore this. So that's what I'll be fixing up throughout the next couple of weeks. But at any rate, the only thing you will need to do, and there is an example within the README, all you'll need to do is pop in either your Gemini key. We're suggesting Gemini right now just because the prompts are really long. So it's the cheapest for input tokens because we don't have a lot of output tokens happening. But for input tokens, which is the prompt, it's very, very expensive if you have too many. So you can either use your OpenAI key. I know they just released GPT-5. I was working with that a little bit. Claude seems to be the best, but it is the most expensive at this time. I would recommend kind of waiting another week until I fix up the prompts to reduce the input size. So right now we're just primarily using Gemini, or if you wanted to use Llama, is what we were using for Ollama. We were using Llama 3.2, and then I was also. At any rate, it's a simple kind of just prompt of poetry run Python. It's in the examples folder and then Tölvera textual UI. When you run that command, you should see a screen pop up. It's basically just saying, here's the little intro to this with a really simple animation. But again, it's before you begin, you have to make sure you have the appropriate model set up in your environment file. And then all you do is hit enter. Here, if you set everything up correctly, it should automatically populate what keys you have available to you or what models you have available to you. So right now I still have Claude if I want. I'm just going to default to Gemini since that's what I was talking about for the next week at least. If you hit confirm, it's going to load up and initialize the model, so everything should be set as soon as you're ready for this. There is a tutorial. I don't have any screen here necessarily that dictates that or shows you, but the key command is F2. So if you hit F2, it's going to bring up this and kind of walk through the process. You can go through this on your own time if you would like. I'm going to go through it right now just to show that we are automatically generating a lot of these sketches on the fly. And if you go through the tutorial, we will be walking through a very simple example. So this is two species, red and green, repel each other strongly. That's very, very simple particle physics happening. If you try anything too complex initially, what ends up happening is we decomposed it a little too much. So the functions might be passing variables that aren't there or aren't defined or aren't passed through the entire sketch. This should be fixed in like the refinement process that I'll talk about, but we'll just generate this and see what happens. It's pretty quick on the API. Flash has a really fast inference time, which is great. It doesn't get everything right immediately. And the more specific you can be initially, at least the better off it's going to be. If you click run, this is when it will throw up the actual Tölvera sketch. So now you see the code was generated over here. You have a sketch description that you can either regenerate every single time, but we'll just run this and we'll keep going through the tutorial a bit more. So it generated all of this. If you want to see what that actually translates to on a visual hierarchy, we can see this. So these are just two species that, as you see the green and red as they approach each other, they kind of propel or repel one another. You can either close out of the Tölvera sketch just by clicking the X here, which is what I normally do. Or if you go back to the actual terminal, you can click stop to, and it will cut out the Tölvera sketch as well. So you can do that. If you go back to the tutorial, so F2, then it'll say, okay, here you can either run the sketch, you can see all the status log, and if there's any error messages, it will be in the bottom left, as well as what's happening. We can continue on. And one thing that's good about this is the refinement process. So as with most co-creative endeavors, what you generate initially probably is not exactly what you want at the end. That's where these little bit of modifications or refinement process is going to help a lot. That's on the right-hand side what you saw. We'll do a simple color change for the demonstration. So this should just change the two colors from red and green to a rust orange and a teal. So this is going to pop in the refinement chat. Let's change the species colors to be a rust orange and teal, please. So it's going to be sent to the LLM, and the entire current sketch is going to be generated or analyzed and then regenerated via the LLM. So if we do color, you're going to see a little bit different colors. So purple is for the refinement, and then if there's any errors, we will see that here. It doesn't take too long again with the inference time for Gemini Flash, which is really nice, but we'll see if this actually runs or not. So now it seems like, yep, changed it to orange and teal, which is great. And I think the rest of the tutorial is just talking about if you wanted to save this and if you wanted to load it up later. Oh yeah, also Control T is the other key bind that I have. I think that's the only other real key bind that's a little bit misconstrued in terms of like you might not necessarily know about it. I'll try to put that in the bottom just to help out with some visibility for this. But that's primarily it for the tutorial. Control T, what I just want to show you is if you're trying to look at the code and the line here extends a little too long, Control T will remove that refinement window. Let's try something in terms of a refinement where it's probably going to fail. Let's try add a new species to make the behaviors all follow one another and increase the particle speed. Now there is no button here that you click. I'll probably update that here in the next few days. But if you want a refinement chat to be sent, all you have to do is hit enter, and then it will go through the process again. This repair button that you see on the right-hand side will only be activated if you try and run the sketch and it fails. So if for any reason there's going to be an error. Okay, apparently that worked. Let's try flocking behavior as well. So let's have the species flock together in their respective species, but still repel each other's species. Now this one has no memory currently, so I'm not propagating all of the changes throughout each subsequent call. That's one thing I wanted to complete this week as well. If you have any other refinements that you would like, love to hear how it's failing, because I assume it's going to fail in totally different ways that I'm not necessarily anticipating, and that's really what we're looking for. Send feedback just throughout the next couple of weeks that I can fix up and make as robust for the community as possible. So let's try to run again. So it flocked, but it's flocking really quickly. And then just kind of continuing is what it seems like to warp to another direction. So let's, each particle should trail is drawn visually to indicate blocking, cohesion. All right, we'll try that. I just wanted to break it a little bit to show you what the repair will try to do. Sometimes it works and sometimes it doesn't. This is where I would love to see examples of it necessarily failing and how it's failing, so I can fix that in the next update. So right now I'm trying to add particle trails. I assume it's probably going to fail somehow. Okay, yeah. This is where it's failing from. It's trying to draw these very slowly. You can see it kind of working. I don't know if that's just because sharing screen and also slow down. But it looks like it's drawing this to some degree. Let me try and close that, but it seems like it's working just really, really differently. The other aspect here is if you wanted to see what any of this is being generated as, you can click View Report, and that's going to throw up kind of a HTML page where you'll see what was sent to each of the LLM calls. So initially, when we're just doing the repelling, we have a decompose, and then it created a species repulsion and dampening force. If you wanted, and you're having any problems, this information sent back to me would be really, really helpful. If you can give me kind of the user prompt of what you sent, and then what the parse JSON was, that would be really, really helpful just for me to see how it's failing and what I can do to fix up the script. There's also another one where you can save the sketch if you want, and you want to mess around with it later. If you wanted to load something, some of the examples that I was doing over here were after many, many iterations and refinements. So what you can do with the system, but unfortunately it will take a very, very long time, are things like this, where I was like regenerating some particle life examples. That one worked pretty well, but again, started from a simple script and then went and added each piece individually and refined it. I would have to fix up some of the code to change anything. You can. So if we go back to, let's see, let's just reset entirely. So resetting will just completely erase everything. So 3 species repel one another but flock together. We'll try that. We'll generate it. And then I can edit some of the colors or something like that to show you if you want to edit anything, one in the terminal, you can in that sketch. Or if you wanted to open up an IDE such as VS Code, or if you wanted to work in Cursor or Windsurf or Zed or whatever your IDE is of choice, you can, and then you can load it back into this to have more or less kind of robust system of running the sketch as well as iterating on it. So we'll run it. Okay, that's flocking together, and then kind of each species that you can see is repelling. We'll just make a simple quick edit here within the colors. So I'll change this to be, I guess, RGB. So we'll just make this pixel like white. And you should see that propagated immediately. So this is just showing that whatever changes you make within that code that you see highlighted will in fact be updated if you run the sketch or if you save anything as well. So another one we were able to create, I think that was, I call it the exemplars because this is the one that actually worked at the end. Slime was one that was fun. And this is taking most of the context from the LLM intrinsically. So if you use particular like slime attributes or slime, I guess, connotations. There's enough world knowledge of it to understand what it should look like. And if you're explaining it pretty appropriately to the LLM, it does a pretty good job figuring this out over time. But again, this is through a few hours really of refinement, unfortunately. So it took a while. We're trying to get that down into a few minutes, obviously. But that's overall the process and what we're trying to do here. You can change the model if you would like. But again, right now we're working primarily with Gemini. That report structure, if anything is failing, is super helpful to me. If you do want to copy, there's a copy button out here that will copy the trace. If you're still failing and you need some help, I'll be online basically the entire of these next 2 weeks to kind of help refine this. Or if there's anything that you would love to see that hasn't been implemented or you see a use for that we're just not really necessarily seeing immediately, that would also be really, really helpful to us to understand how best to help the community on this one. But that's primarily all I had for a full demo. I'm going to switch back to the Discord page to make sure I'm seeing everything. But yeah, if there's anything else, would love to hear your thoughts on what we have. I'm also monitoring the chat right now. Yeah, totally. Thank you so much. And again, if there's any questions, I'll be in the LLM channel or just kind of around seeing what works. Right now, again, if you're trying to do anything too complex with the sketch description, it probably will fail. Let's try something actually that will fail. I think this is just too vague for the decomposer we have right now to be useful. Okay, so it already has an error, and this is where you see the repair icon was highlighted. It's missing a mass attribute, so we have the mass here, but it's looking like within the 346, we're missing the mass attribute somewhere. So I'm just going to hit repair and see if the LLM can actually repair the code for me. Again, this sometimes works, sometimes it's just a cyclical process of continuously fixing and repairing the code. Unfortunately, I need to refine this a little bit. Hallucinations do occur on this one as well. So it will be this process of it fails and then another oh, okay. Well, that apparently worked. I'm not sure what this is creating so far. It looks like everything is repelling each other just a little bit. We see some movement patterns throughout. Let's see. So I'll just try this. This also, might add the species, but then kind of the error we had previously might forget the mass, so we might have to repair it after that. So a lot of this is iterative refinement. Little bits and pieces do a lot better than completely trying to change the script from what I found. If I try to add too many behaviors at once, it doesn't do that. Okay. So it seems like it understood kind of some cohesion and repelling. Let me try to like draw between the species. I have no idea if that made sense to the LLM, but we shall see. I'm trying to draw the basically cohesive forces. So as the cohesion is stronger, as they would be closer together, the line should be thicker, but I didn't indicate that. I just said kind of stronger. So this also might cause the kernel to crash. So this is just, I wanted to try one drawing example for y'all. Okay, so it failed. It's failing on RGBA, so it's failing on the color. Hopefully it will be able to suss out what that is. Okie dokie. Okay, so it's still missing RGBA line 193, so I might try to fix that. Oh, sorry, it's actually before that. Oh, it's yeah, the color attribute in 415. Okay. Yeah, that's actually, let me try and, I'm not sure if I throw in something random, if it would understand this, but we'll see. I'm gonna repair it with that. Just get it closer to what it wanted. I don't know if it was using the individual state or not. We'll try it one more time and then I'll switch over to Discord and read the comments, sorry. But as you can see, it's kind of an iterative refinement stage right now. Trying to fix up a lot of these areas, but the more times it fails, the more I understand what's happening, but I don't know everything that's failing, and I only try so many different things for me. So if there's anything that is helpful, it'd be great. So yeah, it's still failing. I'm just gonna call it on this one. I would have to look at the air output a little bit more, but it's looking like it's still just a color process. So it's looking like it's trying to do an RGB, but in Tölvera it's RGBA, and it might not have the context for that. But I think that's primarily all I wanted to share. Yeah, if there's anything else, and yeah, again, thanks for trying this out. Would definitely be appreciated.